Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics. I welcome you all in our online lab class. First of all, thanks to Almighty that He has given me the ability to take this class. Dear student, here I also hope all of you are well by the mercy of Almighty and carrying on your regular studies, staying at home. Dear student, today we are going to perform an experiment which is very easy, and our today's experiment is determination of density of a solid. That is, student, you know what density is. The mass per unit volume of a solid body is called its density, that we have described in our theory. In theory they said that mass per unit volume of a body is called its density. If the mass of a solid body having volume V cubic meter is m kg, then its density denoted by rho can be expressed as m by V and its unit will be kg per cubic meter, right. That is, to determine the density of a body, first we have to determine the mass of the specific body which is denoted by m, and then volume of the body which is V cubic meter. Then using this expression or formula, we can calculate the density of the body. Dear student, here if the body is regular shape, then we can determine its volume by measuring its length, breadth and height. But if the body is irregular, then we cannot use the expression, but we cannot determine the length, breadth or height. So in that case, we have to determine the volume of the body using measuring cylinder, right. In measuring cylinder, first we have to take some water and we have to determine a water level before immersing of the body, and after the immersion of the body, the water level definitely increase to a certain level. So determining the difference of the two level, we will be able to determine the volume of the body, and by using a balance we can determine the mass of the body, right. Dear student, to perform this experiment, here is our table. In the table we will determine the mass of the body. First column contains the number of observation. We will take 3 readings for our better value. In the second column, mass of the body m kg, then reading before immersion of the body in the cylinder which is denoted by V1, it will be calculated in cubic centimeter, then reading after immersion of the body V2 which is denoted by V2 and its unit is cubic centimeter, then volume of the body which can be obtained by subtracting V1 from V2, that is volume of the body V is equal to V2 minus V1, and the average volume of the body by taking the average of the 3 value, and that should be expressed in cubic meter, because the unit of volume or SI unit of the volume is cubic meter, right. So dear student, let us start our experiment. Dear student, to perform this experiment, we need a solid body of which density is to be determined. We will determine the density of this sphere, a metallic sphere. We need a balance. Here is the balance using which we can measure the mass of the solid body, right. We need also a weighing box and a measuring cylinder. Using measuring cylinder, we will determine the volume of this body. Okay, dear student, now first we are going to determine the mass of the body using this balance, right. Dear student, here is our balance using which we can measure the mass of the body. First we have to level the balance by using this leveling screw. Here are 3 leveling screw. By turning this, you can level this balance, and here is a mercury leveler. if the air bubble remain just exactly inside the circle, then we can say that the balance is horizontally level. First we have to level the balance, then we have to check that whether the balance is okay or not. Here if we rotate this knob and this is the indicator, if the indicator oscillate in both sides of the 0 level in with equal deviation, then we can say that the balance is okay. Here the indicator is oscillating on both sides of the 0 mark, right. So we can say that our balance is okay. Now we have to place the weight, that is we have to place the body of which mass is to be determined in the left pan, and then we have to place the weight of the from the weight box in the right pan. We can stop oscillation of the balance or pan like this technique. Now we have to rotate the knob. So in that case the indicator is exactly in the 0 mark, right dear student. Now we have to know what are the values of the weight box. Here different type of weight is used to measure the weight or mass of the body. Now we are going to measure the total mass of the body, right. Here the mass of this weight is 220 gram and this is 10 gram. So 20 plus 10, 30 gram, this is 5 gram. So total is 35 gram, this is 1 gram, so 36. Now this is 500 milligram, 200 milligram, that is 700 milligram, and it is 50. So 750 milligram. Dear student, so total weight of total mass of the body is, here is 36 gram and here is 750 milligram, right. But we have to convert this value into kilogram. So total mass of the body is 36 gram and 750 milligram. Now we are going to write the value of the mass in the table, right dear student. So mass of the body in kg unit, that will be 0.0367 Okay. Now we are going to determine the volume of the body. Dear student, first we have to know the calibration of the measuring cylinder. You know the cylinder is calibrated in ml, that is milliliter. You know 1 milliliter is equal to 1 cubic centimeter or cc. And here for the 20 division, you can observe that from 30 to 150, 130 to 150, the interval is 20, but there are 10 division. So we can say that every division is equal to, or one division is equal to 2 milliliter or 2 cubic centimeter. Here for the first reading of the volume, the water level before immersion of the solid in the cylinder, you can observe that the water level is exactly at 130 milliliter or 130 cubic centimeter. Now we are going to immerse the solid in the cylinder, right? Dear student, here we are going to immerse the solid in the cylinder, and you can observe that the water level is raises from 130 to 134. That is, water level raises from 2 division, raises by 2 division. Here 2 divisions means 4 cubic centimeter. Okay. So now, dear student, before immersion of the solid in the cylinder, the level was 130 cubic centimeter, and after the immersion of the solid in the liquid, it was 134 cubic centimeter, and the difference is 4 cubic centimeter. Now we are going to take the second reading for the volume. Okay. Dear student, for our second reading or second observation, the water level before immersion of the solid in the cylinder, it is 150 milliliter or 150 cubic centimeter, right? That is, V1 is 150 cubic centimeter. Now I am going to immerse the solid in the cylinder, and you observe that after the immersion of the solid in the cylinder, water level raises from 150 and it is raises by 2 division, right? So similarly, we get 2 readings that are before immersion of the solid and after immersion of the solid. Now I am going to write these 2 reading in our experimental table. Okay. So it is 150 cubic centimeter and 154 cubic centimeter. Here the difference of the 2 reading is also 4 cubic centimeter, right? Okay, dear student, for our last observation, we have raised the water level before immersion of the solid, and the water level is at 170 cubic centimeter. That is, before the immersion, volume of the water is 170 centimeter. Now I am going to immerse the solid in the cylinder, and the volume of the cylinder is raised by 2 division, right? So we can say that the volume increases by 2 division or 4 cubic centimeter. Now I am going to write this 2 reading, that is before immersion and after immersion, in our experimental table, right? Okay, the readings are 170 and 174. So difference is 4 cubic centimeter. So if we take the average of the 3 value, it will be 4 cubic centimeter, but we have to write the value in cubic meter because the SI unit of volume is in cubic meter. So it will be 4 into 10 to the power minus 6 cubic meter, right? Dear student, now we are going to determine the density of the volume dividing mass, this mass, measured mass, by the volume of the body. Okay. Dear student, now we are going to finish our final calculation, that is density of the body. Rho is equal to m by v. Here m, mass of the body, is 0.03675 kg, and its volume is 4 into 10 to the power minus 6 cubic meter. So after the calculation, you will get 9187.5 9187.5 kg per meter cube, right. Dear student, this is our experiment. So, I think you got it. So, but if you have any confusion about this experiment, you can contact with us or you can come to our lab, we will help you. So, thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.